Muy buenos días a todos. Sean ustedes bienvenidos a la 7ª sesión del Foro Virtual Internacional de Tuberculosis 2021. Les recordamos a los panelistas y a los asistentes que esta sesión está siendo grabada y transmitida por Zoom y simultáneamente por Facebook, YouTube y el canal Imagen TV de la Universidad Autónoma de Baja California. Así también se va a contar con el servicio de interpretación simultánea inglés-español. Para mayor información sobre este evento pueden consultar la página de REMI-TV en www.remitv.org. La transmisión de este evento en los distintos canales se realiza con el apoyo del Centro de Estudios y Producción Audiovisual CEPA de la Universidad Autónoma de Baja California, a que le damos las gracias por su excelente apoyo y este trabajo. Este foro está realizado gracias al apoyo de diferentes instituciones, como la Escuela de Ciencias de la Salud, a través del programa de internacionalización de Casa de la Universidad Autónoma de Baja California, la Comisión de Salud Fronteriza México-Estados Unidos, la Red Temática Binacional de Salud Fronteriza, la Red Multidisciplinaria de Investigación en Tuberculosis REMI-TB, el Centro Nacional de Programas Preventivos y Control de Enfermedades, CENAPRESE, de la Secretaría de Salud del Gobierno de México. Y también la Red Nacional de Investigación para Prevención y Control de la Tuberculosis en México. Es importante resaltar que el objetivo del foro es el de generar un canal de acceso a la innovación científica y la colaboración biomédica a nivel internacional con respecto a la prevención, diagnóstico y tratamiento de la tuberculosis bajo el nuevo escenario de la COVID-19 y de esta manera estar preparados para posibles nuevas pandemias. Les recordamos a quienes siguen esa transmisión que se extenderán constancias al haber asistido a mínimo 6 sesiones. Al finalizar cada sesión deberán registrar su asistencia por medio del código QR que se estará proyectando durante la sesión. Para el día de hoy tenemos la participación de 2 excelentes ponentes, al doctor Feliciano Milián y al doctor Francisco Olea. Cada una de las pláticas tendrá una duración de 40 minutos y tendremos un tiempo adicional de 5 a 10 minutos para preguntas y respuestas. Les vamos a solicitar a los ponentes del día de hoy que utilicen un lenguaje pausado, porque recuerden que se estará haciendo la transmisión simultánea y queremos que todo el mundo entienda el contenido de sus ponencias. ¿Sí? Vamos a empezar el día de hoy con la participación del doctor Feliciano Milián, quien es investigador de la Facultad de Ciencias Naturales de la Universidad Autónoma de Querétaro. El doctor Milián nació en el estado de Guerrero, estudió la licenciatura en el FES Cuautitlán de la UNAM, tiene una maestría en epidemiología por la Universidad de Cornell en Nueva York, el doctorado en epidemiología molecular por la Universidad Estatal de Colorado, también en los Estados Unidos. Ha publicado alrededor de 100 artículos científicos en revistas nacionales e internacionales y cuenta con muchos años trabajando con las autoridades nacionales en salud animal, en asuntos nacionales e internacionales, particularmente en el caso de la tuberculosis. El título de la plática que nos dará el día de hoy es Vacunación contra la tuberculosis bovina, experiencias de investigación y perspectivas de uso. Doctor Milián, bienvenido y adelante con su exposición. Muchas gracias.
Ok, doctor, muchísimas gracias por la presentación y aunque ya lo hice en corto, pues me gustaría hacerlo público. Muchísimas gracias a los organizadores del evento y en especial al doctor Gilberto López, quien directamente me hizo la invitación. Y pues con mucho gusto estamos aquí para platicarles un poquito de nuestras experiencias en este tema y trabajando con esta enfermedad que aparentemente ya la habíamos controlado, casi eliminado, y parece que ha tomado un repunte y nos está causando muchos problemas. Entonces, como ya lo mencionaron, el tema es vacunación contra la tuberculosis bovina. experiencias de investigación y perspectivas de uso. Y antes de entrar a mis diapositivas, me gustaría comentar que yo soy uno de esos investigadores en este campo convencido
who is convinced that vaccination has a great potential and that it should be used under the control programs for this illness, especially in those countries who suffer from this problem in the cattle or wildlife. And I repeat, I am convinced that this is a strategy that should be used under those programs already in place to control this. And I always like to start my talk with this slide where we always ask ourselves this: if the tuberculosis is so sensible, why haven't we been able to eradicate it? And it is immobile, it is intracellular, and it survives for a very short period of time. It is susceptible to heat and sunlight as well as pH changes. And if we give it everything it needs to grow, it grows extremely slowly. It takes it about between 4 to 8 weeks to grow. The transmission is respiratory in 90% of the cases. This means that it needs very close contact. And out of 100 infected people, about 10 people develop the illness. So if this has so many things against it, why is it still an issue to us? That's what we have to reflect on today. It is impossible to talk about TB or bovine TB without speaking about human TB. Even though you probably have already seen the data on this slide, what I would like to point out is that within all of these issues that has to do with TB in the public sector in humans, M. bovis is the pathogen of the illness in cattle. So it is important to take this into consideration because M. bovis has a lot to do with this. Well, TB by M. bovis is what it's our topic at hand today. Well, talking, and later Dr. Francisco is going to talk a little bit more about this. This is a zoonotic illness. It is the second most important illness as a unique agent. Thousands of millions of dollars are spent on control and prevention programs in many countries. And as far as cattle goes, it is the cause of many losses, direct and indirect, on as far as live cattle and their products. So it is an illness that we urge, or we have to urge to try to stop it. How do humans get infected? Well, by direct contact with animals, or most common, through the products that are contaminated and that had not been treated properly, because they're not treated in proper way, or people drinking non-pasteurized milk. Now, the problem with M. bovis is zoonosis. So we have to remember certain things. Tuberculosis by M. bovis in humans is equals to the cause of caused by MTB, which is clinic, radiological, or pathological. Now, M. bovis is very similar genetically to MTB, and it has a 99.95% of similarities molecularly, and it has a lot of. Now, the case of M. bovis in human cases is not well documented, and there's a reason. The diagnosis is based on bacilloscopy, and the means used do not favor the growing of M. bovis. And I'm talking about the methodology that is used in the health sector. And we have to remember that M. bovis is naturally resistant to one of those medicines that are used to attack the illness on a patient. M. bovis very commonly is extrapulmonary. Therefore, it is also harder to be detected. All of this complicates the situation, and it makes M. bovis a very high public health risks. Some of the work that we've done in the area of Querétaro, which is a zone with high prevalence of the illness in cattle, and where there is also human TB, we've been seeing how the human tissues, as well as the tissues from animals, share the M. bovis patterns. For example, in this case, three samples of gastric juice or human gastric juice follow the same pattern of 7 from bovine. So we have seen that M. bovis has been participating in the cases of human TB. Getting a little more into the information and data that we have on these cases, we see where we got the isolated from urine and gastric juice and from sputum. And we can see that M. bovis is participating in the cases of human TB. In this case, the proportion that we have found on human TB cases by M. bovis was about 6%. This news has been spread in our country, where it's said that Mexico is within 86% of the eradication phase for bovine tuberculosis. And this is true. The campaign has been very successful, but it has been very successful for the cattle, for beef cattle, but not for milk. So that's where the issue is. Now, the reason why it works in one type of cattle compared to others is obvious. In the case of beef cattle, there's a very important economic incentive. When it comes to milk production, it is not the same story. Now, what are the issues that we're facing? Well, officially, prevalence is recognized at about 16%. Now, what we have done through different research that we have done, we have found that animals with are around 17%. We have found a prevalence with over 60% in some cases. And we also have found that the participation on TB campaigns in the milk industry is very low. 30% of these have had some kind of participation on the different campaigns, and it is very limited, and it's basically focused on complying with some requirements so that they can get an economic stimulus. But they're not really focusing on trying to fight the illness itself. We do not have money for compensations. In other words, the campaign indicates that tests have to be done and animals have to be eliminated. However, if those animals are not eliminated, they're not paid. They don't get paid because we don't have the resources, which is something that producers do not like at all. Obviously, we have a lot of commercial pressures. And I'm talking about Mexico. Mexico has an important market with the US as well as selling animals for milk production. And of course, the US do not want to receive animals that are infected with TB. So Mexico has the commitment to eliminate that illness in all of the national territory, and that national territory includes the milk production cattle. So I repeat, that's the market for which is really important for our national producers, and we export around 1.5 million heads of cattle from Mexico to US, and the US has Mexico identified at different levels of disease control, and some states can export more than others. And of course, we would like for all of our states to have the same opportunity of exporting with the minimum requirements. But in order to accomplish this, we need to reduce the prevalence of the illness. And in order to do so, we need new strategies because the ones we have are not enough, especially for the milk production. So what are some solution alternatives? We're very familiar with some of them. We have an official norm which indicates that animals have to be tested, and those that result positive have to be sent to be killed. But we have problems for these to be successful. Our tests, remember that our tests are not very reliable, and there's no compensation, and as I had mentioned before, and of course animals that are you have to get rid of, then you have to replace, and they're expensive. Producers have production, they have to comply with certain production quotas, so they have to try their best to comply with this. And something that's really important is that the prevalence of this illness is very high. Officially, it is mentioned 16%, but it might be above that. And in conclusion, it is an alternative which in the milk production industry has not been very well accepted. Now we have a second alternative to solve this problem, which is handling the infected cattle, where certain specific actions would have to be established to reduce transmission. For example, separating the animals, which means forming a new stable and and as well as other practices. However, this solution or alternative has not been very well accepted either by the producers because it represents a difficult handling of their cattle as well as it increases their cost. So very, very few producers have used this alternative. Another alternative is the one that we propose, which is to integrate vaccination to the current control programs that we have in place. This is one of the alternatives, and producers are very open to adopting this strategy. And currently, there is a lot of interest on initiating this activity to implement this new strategy. A question that a lot of people have asked is why don't we apply this vaccination? And the response or the answer is very simple. It is logic. If we vaccinate, the cattle is going to generate an immune response. And if we want to do field test or prevalence test, the animals are going to respond to those tests. And we're not going to be able to know whether the response is because of the vaccine or is it because of a natural infection. Now, this is absolutely true. However, as I was telling you, in the particular case of Mexico, as well as in some South American countries, the milk producer does not participate in these campaign activities, or they do it in a very limited way. Therefore, having an interference of is irrelevant because at the end of the day, they're not doing anything. They're not doing any of these tests. On the other hand, our colleagues in the United Kingdom, which is the research group which has worked the most in this field and the one that has the most money to do so, has generated or has some antigens which, at least in lab tests, it seems that they can make a differentiation between vaccinated animals and non-vaccinated animals. So this could be something that could be incorporated to these TB tests for animal to be able to differentiate vaccinated animals from non-vaccinated animals. So what is our current situation in Mexico? Well, the bovine TB starts at the milk production units. Up to date, the control programs have not been able to eradicate this disease in this kind of animals. The control strategies, the official control strategies have not been accepted by the producers. We have organized at least a couple of forums where producers, organizations, and leaders have participated, as well as authorities and academics. And the conclusion that we have come to is that vaccination has to be incorporated to the current control programs. That has been the conclusion or the most important conclusion that we have come up to. Now, when I was talking about the vaccine, I would like to emphasize that what we are talking about is the same vaccine that is utilized to protect kids, the ones that's applied to kids. And it has been applied for over 100 years. So we're not talking about any other kind of vaccination. And even though attempts have been done with some genetically modified strains, from the legal point of view, for the health sector to accept that we're using the same vaccination that is being utilized in the humans, and we're not using any other kind that could potentially have a risk for humans. And we have not found a vaccine that which has proved to be more efficient than the BCG vaccine. So we continue working with this. We have a series of attempts of modifications to those vaccines that have been utilized with many different protocols, from the vaccination with BCG as well as the booster from the beginning with BCG, and then with different protocols and different molecules that can serve as boosters in order to increase the immune response. There is a work by Dr. Golden Mayer which gives a summary of all of those attempts and differences that have been performed, and I'm not going to get too much into detail about this, but I would like to mention that all of those, well, that there has been a series of options as far as vaccination protocols in order to try to improve the immune response, which have been in general the results of all of these experiments. Well, the first one is that it induces to a strong immune response, which at the end of the day is what we are looking for. Especially we're looking for cellular responses. As far as research and experiments, it has been shown that when animals are vaccinated, we have less animals affected and less bacteria by injury, and it protects just as any other vaccines, not precisely against the infection, but if we see on the left, we can see that it protects against the disease. And then something that we had mentioned is that does it protect better to M. bovis or MTB? But we have to remember that it has also been shown that the booster with protein improves the response. And the question in the air is, and this is in general worldwide, is what is the result of vaccination in a long run? That's our homework, and it should be our goal for a near future. Now, what's happening with vaccination around the world? We're not the only ones interested on this issue. And we're not the only ones interested in applying vaccines. We all have our issues and we have different problems to solve, and we're looking to find a solution to this problem. For example, what is the US doing? Well, they are trying to solve their problem in wild, with their wild animals. The US has an important TB issue with deer in the in states such as Michigan near Canada. So they're trying to develop a vaccine to try to finish with, to try to attack this problem. What's happening in New Zealand? As you will know, New Zealand has a low prevalence of this disease in cattle. However, they have a problem with their wild animals. So what are they doing? Well, they in fact already have a vaccine and they're applying it to this animal, which is the reservoir of the animal in their country. So they're also working or using vaccination to solve their problem. What's happening in the United Kingdom? Well, the United Kingdom is the country that has invested the most money to developing a vaccination. When they started looking into how to solve this problem, they tried, because the reservoir is this badger type, they tried reducing badger population. And of course, animalists were opposed and they said, no, why should we eliminate badgers? Maybe we should eliminate cows. And then they faced a conflict and they had to look for other solutions. And that's how they obtained resources in order to see the role that the vaccination would play, not only for cattle, but also for wild animals. And it has been shown that the risk of acquiring this illness has gone down, obviously, by vaccinating badgers. They are not using this vaccine on cattle because of the on cattle because of the strict rules and regulations that they have in their country, which does not allow them to do so. But what's Spain doing? Spain also has their problems very centralized in a kind of a big acid reservoir, and they're trying to see how they can get the vaccination to this kind of pigs so that they can finish with the problem in this species. Other countries such as Chile has begun to start doing their first field research, and they had started utilizing their vaccines on cattle. I don't have any reports from the results that they have obtained, but it is good to see that a Latin American country is already using this resource. Very quickly, what have we done in Mexico? Well, in Mexico, through different experiments, we have shown what I had mentioned before. We used the fifth strain, and it induces a strong immune response, and this has interferon gamma in blood, and this is the best indicator for the efficiency of the vaccine. And we've seen that this can last up to almost 2 years. Close to 2 years, the concentration of that response goes down. We have also shown that vaccines reduce the number of injured animals as well as the magnitude of these injuries. We see here, for example, under the control group, all of the animals present injuries, while on the vaccinated groups with a specific protocol, the number of injured animals is reduced considerably, as well as the magnitude of the injuries. We can see under this table the injuries under the control group compared to the group which was vaccinated with BCG vaccination and then with different booster molecules. We've also shown that vaccine reduces the number of injuries within vaccinated animals, and it reduces them considerably, even though we cannot always see important differences when the statistical analysis are done. And there's a reason for this, a very particular reason for this. An animal that has a lot of injuries increases the variability, and it makes the and we have also seen that the vaccine reduces the bacteria charge by injury. We've also seen that there's a correlation between the interferon gamma, the blood interferon gamma concentration, and the magnitude in the injuries. The more concentration of interferon in blood, less number of injuries. And this supports what I was mentioning before, which is that interferon gamma is the best indicator for vaccine efficiency. Something that's very important is also that we have shown that this behavior of immune response to the vaccine repeats itself when it's done on the field, such as in this case where we use 400 gestant cows in different cows, and there were no abortion cases, which indicates that this is a secure vaccine to be used in these pregnant cows. All of this work has been repeated utilizing goats as models because goats are less expensive to be handled, and feeding them is less expensive than bovine cattle, and the results have been very similar. In this graphic, which is probably a little difficult to see, but this is an animal from the vaccinated groups and utilizing a booster for the vaccine, while these on the lower right-hand side is of a controlled animal, which presents a lot of injuries after the challenge with field strains. Now, we've also seen that some nanoparticles, which we thought could improve the immune response, really didn't improve this response. Obviously, at the concentrations which we used, we did not do an area of dosification to see the response beyond what we utilized, but nanoparticles could have a good effect, but in this case, it was not what we had expected. Now, in this commercial commitment that we have with the United States, we have made commitments and we have signed binational agreements in order to control and eliminate this disease in both countries. And every certain period of time, we come up with strategic plans. In this case, we have these that goes from 2013 to 2018, where the US recognized that around 12% of our national territory where the illness has a high prevalence. The remaining territory of the country, about 12%, includes non-recognized zones, which are populated by mixed and beef type of cattle. These zones have the potential to be recognized. These zones have a prevalence ranging from 0.1 to 0.2. Now, under this strategic plan, as you can see in this slide, as you can see, it has point one where it basically specifies what the campaign indicates, what the campaign currently indicates. But under point two, under these 2013 to 2018 plan, they were already thinking about reducing prevalence in milk zones so that we would reduce that prevalence from 16% to 5%. We had come up with certain plans to do some pilot programs in Aguascalientes, Querétaro, and other places. Unfortunately, the plan was just a plan because we did not have the resources necessary, so we could not conduct this work as it was planned. However, we are open to vaccination. So that there are many people that are interested in vaccination, and our door is open for those who are willing to do so. What is our next step? And not only for Mexico, but worldwide, are field tests. We need to do field testing in order to see that the strategy works, so that we can show that vaccination has the capacity of reducing the incidence and prevalence of this illness. Well, as all of the vaccines, if we add some strategies of work strategies, we can improve the response that we might get under a real control program. For example, intensify waste, increase biosecurity measures, etc. As in all of vaccinations, I repeat, this is a strategy where what vaccination tries to do is to avoid infection. If we see this as a water flow, where here we could have the control of that water current, everything that we could add to the herd, such as the strategy of intensifying waste, we could accelerate or slow down, or depending on the possibilities of each producer, we could
el tiempo en limpiar un hato de la enfermedad,
we could let more or less water go by. Now, in conclusion, as I had already mentioned, vaccination against FoVI-TB sorry, should be incorporated
de la incidencia y por consecuencia de la prevalencia
in order to accelerate incidence and prevalence in the milk herds. I don't want to finish my presentation without thanking each and everyone who helped develop the work, especially the financial sources, CONACYT, INIFAP, which gave direct support for these works. Of course, Pronavive, who also helped us a lot at the beginning with the production of the vaccine. Many colleagues with whom we have collaborated, support personnel, and of course producers who have lent some of their animals in order to conduct our studies. And with this, I finish my presentation, and I can now open the forum for any comments or questions that you may have. Thank you, everyone. Thank you, Dr. Milián, for an excellent presentation. We have some questions. We have had a very active messaging. I'm going to go ahead and start with the questions, Doctor. According to your experience and considering that vaccination has shown to work at an experimental level in the field and that you have used SAT6 and CF10, why hasn't the vaccine been approved in Mexico, especially in places where they have a high number of milk cattle? Well, in our government, it's very common that with new administrations, there are changes on directors and managers very frequently. We started trying to get this approved, and then an administration change occurs and everything goes down. That's one of the reasons why we haven't been able to advance on this issue or on this topic. Now, we have to remember that we have tried registering this vaccine, and for which we obviously needed to present or submit all of the documents required in order to register a vaccine. And what they asked from us were field tests. So we're in this vicious circle because we cannot do field testing if we don't have resources, and we don't have anyone who would be able or willing to give us resources in order to do these field tests. So what we've been doing is we've been working with interested producers to whom we sell the vaccine as a recuperation fee, so that we can generate the vaccine and we can generate information so that we can start utilizing officially. But authorities are open to the use of this vaccine under this research context of field testing. Another question. The question is, you were saying that vaccinated animals show a decrease on injuries. And what are some of the implications of the vaccines? Well, the presence of the infection of bacillus in milk has been demonstrated a long time ago. Now, what I was telling you is that the transmission of the cattle TB to humans through consumption of non-pasteurized milk. That is the risk. It has also been isolated. Well, the fresh cheese bacillus has also been isolated. Studies in the US have shown that M. bovis is present in many cases of human TB precisely within Hispanic populations. And those Hispanic populations consume a lot of fresh cheese. And if you could see it, it's the amount of fresh cheese that gets to the U.S. is alarming. So that's the fundamental reason. More questions. The next question. Would it be a good strategy to implement typification of microbacterium to all of the patients in zones where cattle activities take place, referring patients who have been confirmed with TB and do typification? Well, it would be desirable, but it is not very practical and it is very expensive. That is the issue. We have contemplated this possibility between the different authorities within the health sector, and we have come to the conclusion that it is very difficult because of its cost. However, for some patients, for example, those who do not respond to a traditional treatment, this could be an option, but only in under this case. Another question: who is in charge of detecting TB on the in livestock? Well, the TB campaign, which is a part of animal health sector, which is also a part of Senacica, under an epidemiology surveillance in all of the country. They are the ones who are responsible. A lot of participation from the different departments of the livestock sector. There's a joint effort that takes place. Okay, another question from Danny Zaratecas. How many vaccines for animals exist in Mexico and where are they applied? Officially, none, and they're not applied. For TB, for tuberculosis in cattle, they're not applied. Okay, very well. I personally have a question, Dr. Milián. You were mentioning that Englishmen have developed a vaccine which is able to identify vaccinated animals from infected animals. Do you know what the fraction of the microbacteria is used to identify the vaccinated from the non-vaccinated animals? Yes, of course. Specifically, there are two. Well, in fact, there are three. One of them is the CFP10 and the other one is the SAP6. And what happens is that under this process, which the vaccine has been under to reduce the what they're like. Currently, field strains can produce those proteins, CFP10, and there's another one that I cannot recall right now. But if the field strain can produce it, but the vaccination strain does not have it, then those antigens have to be added to the tuberculin test precisely to be able to identify the different animals. Just that simple, and it is not the vaccine what they have are the proteins that are incorporated to a diagnosis test, CFP10 and SRF10. Now, with all of these things that have been happening worldwide with COVID-19, it is evident that some advances of a decade or more has been accomplished. Have you considered the possibility of developing RNA messenger type of vaccines now that we have the technology available? Yes. We have done some attempts, but if we want to use these types of vaccines, recombinant vaccines would need to have research work in order to get all the documents required so that we could prove that this new vaccine would not represent a risk to humans. And perhaps the work to get with this vaccine to the cattle will take longer, will take even longer, but there have been some attempts on this. That's another issue. Yes, that's a completely different issue. Okay, well, Dr. Milián, we thank you so much for your participation and thank you for answering all of these questions, and thank you. On behalf of all of us, on the contrary, thank you so much. You should have my contact information in case any of you have any additional questions, and if you would like to send them to my email, go ahead and I would gladly try to answer them. Thank you so much, and I'll stay here to listen to Dr. Francisco's presentation now. Okay, now we're going to welcome Dr. Francisco Olea, who is an associate professor in the Pathology and Medicine Department in the School of Medicine Zoology in Western University in Ontario, Canada. Francisco Olea Popelka is an epidemiologist oriented to the strategy of One Health, using the One Health approach to address the challenges posed by zoonotic tuberculosis globally, and he has worked with different government agencies as well as different professional health groups. With a lot of experience in this field, he is recognized internationally as a leader in the zoonotic tuberculosis. Now, this type of tuberculosis has been recognized with a worldwide coverage. He has received different awards from the WHO and the OEA, as well as other important organizations. He has published over 80 written articles, and he's part of the bovine tuberculosis published in 2018 by International. Now we are going to have his presentation, which is titled Using One Health Approach to Address the Challenges Posed by Zoonotic Tuberculosis Globally. Go ahead, Dr. Olea, please.
Thank you very much, Francisco, for that introduction. Good morning, good afternoon, everyone, wherever you are in the world. Before I start, I want to thank the organizing institutions and the colleagues, especially Dr. Raquel Muñiz Salazar, Dr. Dora Luz Flores, and especially Dr. Alejandro Pereira from Mexico for inviting me to present here. It is certainly a real honor to be presenting in this conference, to be presenting after Dr. Feliciano, who is a colleague that I have read most of his scientific publications over the years. So it's great to be surrounded by this type of colleagues. So thank you very much. For today, what I would like to do in this presentation is emphasize in these 40 minutes some key aspects of zoonotic tuberculosis, but mostly share with you some examples of how we are using the One Health approach. And these examples will be examples in the past 10 years, some very recent one in the last 2 years, and some activities that are being planned. And this, as the Francisco say, right now as a veterinarian, I am a veterinarian, but I have the honor also to be working at the University of Western Ontario in Canada at the Schulich School of Medicine and Dentistry in the Department of Pathology and Laboratory Medicine, which is the first medical school in Canada to start an official One Health program. So they are one first example of how One Health is being implemented in the real world. So what is One Health? Before we move forward, what is One Health? One Health is an approach, a collaborative, multi-sectoral, and transdisciplinary approach that can be applied at different levels in the world, nationally, locally, or regionally, or globally, aiming to achieve optimal health and well-being, recognizing the most important aspects of One Health, which is the interconnection between people, other animals, plants, and the environment we all share. It's very important to notice in this current definition of One Health that is not just collaboration between human medicine and veterinary medicine. Certainly is a key aspect of, but One Health, as you will see with some examples I will provide, as I like to say, is beyond the medical or the health sector. One Health officially started being recognized as One Health in the year 2008, as a political reality, but as today, recently, and these are some recent examples, the G20 summit that occurred a few months ago, the G7 summit that occurred in the summer of 2021, have recognized and endorsed fully the use of One Health to move forward after the COVID-19 crisis. Also, other institutions such as the USAID have even called for the development and creation of a One Health force. More recently and less academic, you have even celebrities such as John Oliver, you know, quite funny and certainly not using an academic language, but still the fact that celebrities and main media are starting to recognize One Health also is a very important development. If you want to laugh, you can watch this YouTube video, which actually is quite interesting and how he brings One Health into these conversations around COVID. But moving into tuberculosis, and very briefly, it is important to recognize that over the last decades, 3, 4, 5 decades, perhaps, if you want, tuberculosis has been the #1 infectious disease in the planet caused by a single infection agent. When we think about tuberculosis in humans, of course, we are referring to the disease caused by Mycobacterium tuberculosis. And this is a disease that technically it could affect anyone, but in reality, it's a disease of poverty or of communities of economic distress, vulnerable, marginalized communities, or people that have some very specific risk factors. As Dr. Feliciano mentioned, 1/4 of the world population, so that means approximately 2 billion people, actually are infected with these bacteria. It's estimated that it's infected, but only a certain proportion, around 10%, progress to the development of the disease. And again, this has to do with factors decreasing the ability of the immune system to contain and win the battle against these infections, such as malnutrition, diabetes, HIV, tobacco, or other conditions. In the very recent published WHO report, some important things to highlight is that, again, approximately 1.5 million people die from tuberculosis. In the year 2020, approximately 10 million people were diagnosed with TB, suffering from the disease. But what is really more important is to put this one into perspective on how the planet is today. And as reported by the WHO, In the year 2020, it was the first time in the last 10 years that the number of TB deaths increased. And this has been attributed to COVID-19, to the fact that fewer people were diagnosed or treated or were able to seek services for tuberculosis. And that's something super important to consider, especially also due to the fact, and I will show you an example, that fewer resources for essential TB and research and development also were available for tuberculosis for obvious reasons. One of those key aspects of tuberculosis at the global scale is diagnosis and early detection. And it is important to mention that any and all of the current diagnostic tools to identify or diagnose human patients with tuberculosis, none of them, even GeneXpert, the latest technology, none of them, the one of these methods that are used on a routine basis, on real patients there in the real world, none of them can differentiate between different members of the Mycobacterium tuberculosis complex. And when we look at the Mycobacterium tuberculosis complex, this group of bacteria, closely related bacteria, of course, Mycobacterium tuberculosis and Mycobacterium bovis are the most studied, well known for their impacts on human health and cattle, bovine health, and other animals, as we will see very soon. But also it's important to know that there are other members of the Mycobacterium tuberculosis complex that can and are playing a role on zoonotic tuberculosis. Very briefly, since Dr. Feliciano already made an excellent presentation, when we think about bovine tuberculosis, it's of course caused by Mycobacterium bovis. When the disease advances to later stages, it can look in many different ways, but these are some examples of how clinically animals will look if the disease progresses. The pathology of the disease is the typical development of chronic granulomas or tuberculous lesions that can affect the lungs, but also other organs and certainly the lymph nodes. The main reservoir of Mycobacterium bovis around the world is bovines, cattle, but it is important to recognize, and this is really important when it comes to zoonotic tuberculosis, that Mycobacterium bovis can indeed infect and cause disease. Those are two different things: infect and cause disease in a wide range of vertebrates, including humans. For example, here are some pictures that I was able to take in South Africa in Kruger National Park. Lions are infected and affected by Mycobacterium bovis. Black rhinoceros. These are the lungs of this black rhinoceros that die. And all the molecular tests identify Mycobacterium bovis. Kuru, other examples of a species. You can see here the lymph nodes affected, and at necropsy, you can see the typical granuloma development lesions. As Feliciano already mentioned, in Ireland and the United Kingdom, the wildlife reservoirs which challenge the control of the disease in cattle are the European badger Meles meles, and actually the Irish government already started vaccinating badgers with BCG, with the Bacillus calmez-Guerin. So a nice link with the previous presentation. And actually, Professor Paul van Helden and Anita Michel from South Africa, they have done an amazing work in describing, and they are currently working as we speak, on how Mycobacterium bovis is affecting different wildlife species in South Africa, and also they have done research outside South Africa. With Professor Michelle Miller, we wrote this manuscript in the year 2013, bringing the concept of One Health to tuberculosis, describing less known examples such as the one as the possums in New Zealand, or the wild boars in Spain, or the deer in Michigan. We described some other less known cross-species infection and disease between humans and other animals. So we have started this work in the year 2013 when thinking about zoonosis. And when moving to the topic of zoonosis, I like to use this definition from the CDC in the United States. Why? Because it reads like zoonotic diseases are caused by infections that spread between, and that's the key word for me, between animals and people. I will say people and other animals, but that's just language. The between part is important because the arrows, as you can see here, goes in both directions. And that is really, really important because indeed, other animal species can transfer pathogens to us humans, but also it's important to recognize that we humans can also transfer pathogens to other animals. Here is an example, also in Kruger National Park of South Africa, of a male elephant, actually a mature old elephant, 45 years old, that was spotted by a tourist. They called the veterinarian, my colleagues, and when they opened, the tourists say the elephant is having a nap. The elephant is sleeping. Well, the elephant was sleeping forever, did not wake up ever. And when the veterinarians approached them and did the necropsy, they found typical tuberculosis lesions. Further laboratory work confirmed by different methods that this was actually Mycobacterium tuberculosis, human TB, not Mycobacterium bovis, but human TB. This has been published officially and recently in 2019 in Frontiers, and also Nature, the scientific journal Nature, have published an article of the work that Dr. Michelle Miller and many colleagues here, as you can see, did with this very first wild, free-ranging African elephant found dead from human tuberculosis. And why this was so important? Because it is well known that elephants can get Mycobacterium tuberculosis, and this has been well studied in the United States and other countries, you know, Asian countries in which humans have a close interaction with elephants. And it's well known that Asian elephants have suffered from Mycobacterium tuberculosis. But the finding of an African elephant and a free-ranging elephant, not an elephant in a temple or a zoo or with direct contact with humans, was a very important finding. The reason I mention elephant is because we are conducting some work currently in Victoria Falls in the border between Zimbabwe and Zambia. And the reason we are working there, conducting research as a professor, is because we have this scenario in which elephants have close contact with keepers on a daily basis, but also with tourists, because tourists use the elephants for safari and for touristic attractions. And this is an area also in which Mycobacterium bovis has been identified in lions, and different and new mycobacteria from the complex have also been identified in other wildlife species. So it's a very complex scenario here in the border between Zimbabwe and Zambia. And of course, it's a scenario in which there is Mycobacterium tuberculosis or human TB. Also, we have bovine tuberculosis caused by M. bovis, and also there is wildlife tuberculosis caused by Mycobacterium mungi. So as you can see, a very complex scenario in which not only one Mycobacterium species is the species of concern, but it's a very complex situation, especially when you see that this type of activity occur on daily basis. Elephants, human, warthogs, and then we know that warthogs also interact with mungi and other wildlife species. So as you can see, it's a very complex scenario that needs to be studied. And we have been doing that, studying elephants for seroprevalence, seroresponses to tuberculosis, you know, to human tuberculosis. We have published some findings, and also in other regions in South Africa. Here we have some publications as well in 2019 about tuberculosis in lions or other side effects of treatment of tuberculosis in North America when elephants, and due to the economic situation in North America, actually elephants can be treated and have been treated for human tuberculosis. If we get out of Africa for a little bit and we move to India, it's very important, again, that India represents a complete different ecosystem, if you want, all right? Sorry, I did something here. I didn't mean to do that. Here we are. In India, over the years, colleagues have published scientific evidence to indicate that both Mycobacterium tuberculosis has been found causing not only infection, but also lesions and in milk of bovines, and also the presence of Mycobacterium bovis in humans. And these publications, some of them were old, but when we have recent publications in 2017 about, as you can see, the presence of Mycobacterium tuberculosis in cattle or Mycobacterium bovis in humans. And the colleagues there have indicated that this evidence that Mycobacterium tuberculosis is present in cattle and not just infecting cows, but also causing lesions and being present in milk ready for human consumption pose a serious public health, especially in scenarios in which social, cultural, and in this case, religious practices facilitate the interaction between humans and cattle. So it's very important to know that, and more papers have been appearing recently, again, in which even sometimes there is a mixed infection of Mycobacterium tuberculosis and cattle. And very recently, 2 years ago, more emphasis has been placed on Mycobacterium oryges as a cause of both bovine tuberculosis and zoonotic tuberculosis in this particular scenario of India. But coming back to North America and getting closer to home, Mexico, and actually I should say the border with Canada in Michigan and the United States, when we are focusing on this area of the world, we are thinking more about cattle, fresh cheese, humans, and deer. We can summarize it in that way. And I'm working with a physician in Michigan. I'm located here very close to the border between Canada and Michigan in my university. And there has been some cases of Mycobacterium bovis in human, and this is related in general to the specific scenario of white-tailed deer being the main reservoir, the wildlife reservoir in Michigan, which pose serious challenges to control the disease in cattle. So now focusing specifically on zoonotic tuberculosis caused by Mycobacterium bovis in humans. I wanna emphasize the work that we have been doing with an NGO, a non-government organization. This NGO is over 100 years old. It's called the Union, the International Union Against Tuberculosis and Lung Disease, which have for many years a subsection, which is called the Zoonotic Tuberculosis subsection. I was invited to participate in this organization, to be involved, to volunteer in the year 2010. And what I immediately like about this NGO, is not a government organization, it's not a university, it's not a private institution, no, it's an NGO. There are principles. There are three main principles on every and anything they do is know, share, and act. So in simple words, they bring together the scientists, the knowledge producers, people like me, professors, scientists, doctors, nurses, veterinarians, etc. But they equally emphasize the importance of communicators, journalists. And then at the end, also, they emphasize heavily the public, the activists, the social workers, the anthropologists, and the people in the field. Not just the people making the rules, but the people implementing the rules. And working with this institution, from me, a person in academia, most of my career has been a wonderful synergy, a perfect match, I would say. So I would like to share with you, go back in time, 11 years now, to the year 2010, when I joined the zoonotic tuberculosis subsection, and people ask me, all right, Francisco, but what is the real incidence? How many people have zoonotic tuberculosis? How many cases are there in humans caused by this cow pathogen, as the physicians used to ask me? So the real question, more technical question, was, what is the true evidence of M. bovis in humans? And the answer was very simple. I don't know, because nobody knew in 2010, and to be quite honest, today, nobody knows still today. But the challenge was, and it was very well described by colleagues at the CDC in this paper in 2010, why has zoonotic tuberculosis not received much attention? So this is very important to understand. We are in the year 2010 here. At this time, tuberculosis was officially classified as a neglected disease. And the best estimate that we used to have at that time was the estimate for the United States, which very accurately indicated that only 1.4% of humans suffering from tuberculosis in the United States actually were infected with M. bovis. And this was done by the CDC with molecular typing, and it was quite accurate. So at a national level, in 2010, the only country that had a good estimate for zoonotic TB was the United States. And therefore, of course, what did everyone else do? Well, if it's in the US, it's 1.4%, that's it. So it's marginal, it's irrelevant, it doesn't matter. Let's apply this number for everywhere in the world. Well, you don't need to have a PhD in epidemiology or a Nobel Prize in science to understand that applying a 1.4% from one country is not really a good idea to other countries. So that was my first argument, that say we need to get away from this 1.4% because it's not representative. And even that, if it's only 1.4%, if we play that game for 1 minute, I told the WHO, well, if you have 9 million or 9.5 million was in 2010 patients suffering from this, we are talking over 120,000 people with M. bovis around the world that are not being diagnosed and are not being properly treated, and many of them are dying. So can we start a conversation? So really with those simple numbers and a simple calculator, we start a conversation. So the reason I say time and place is very important, because even that percentage, and Feliciano already mentioned this, even this 1.4% overall in the United States is not even representative for the United States, because in those days, clear research in the South California, in San Diego, indicated some very concerning results, that actually 6% of TB patients in San Diego were infected and suffering from zoonotic TB, and 45% of children actually were zoonotic tuberculosis. And the obvious epidemiological characteristic of this finding is that the vast majority, the overwhelming majority of these people suffering from zoonotic TB were of Mexican origin. And then further research indicated, as Feliciano mentioned, that the main risk factor was the consumption of queso fresco, unpasteurized fresh cheese. So that was a niche in North America, in the United States, that did not match the 1.4%. And then at that time, when you start looking literature available at that time, Feliciano, sorry, your paper at that time was still in press, indicated that surely 6% in some parts of Mexico, and if you are looking HIV versus not HIV, all those results change. In African countries, vary from 0.4 to 10% of people with TB were actually infected with Mycobacterium bovis. And then when you keep looking at the literature, it really depended. And as I like to say, what you find depends on where you look, when you look, and how you look, which techniques, and who you select for using. And all these studies here, none of these studies here were nationwide, representative of the entire country, were the typical academic studies that we professors do in university with a reduced sample size, but still indicated clearly that the 1.4% was not a good idea to extrapolate it to the rest of the world for obvious reasons. Especially since we know that the risk of zoonotic tuberculosis vary depending social, cultural, religious practice, such as, first of all, the prevalence of the disease in cows, or in bovines, whether or not the milk is consumed pasteurized, HIV, and really other social, cultural, and economic factors, and we already mentioned the fresh cheese. So in 2013, still the disease, bovine tuberculosis and zoonotic tuberculosis at the WHO was officially listed as one of the 7 neglected zoonoses. Here you have it, officially called a neglected disease. So we decided to start working at the union. This is a picture taken in the conference at the union. And here I want to mention and again acknowledge the work of a Mexican colleague, Dr. Alejandro Pereira, which at that time we were working very, very closely together as a program chair. He was the program chair and I was the program secretary in this NGO. Here we are with Dr. Tim Rodwell, the physician in San Diego that published some of those very eloquent results. And we have a colleague from Uganda, a veterinarian, Adrian Mugonge, and we start working on this campaign to create global awareness. First, let's create awareness of this disease. So as a professor, I started working at that time with my student at Colorado State University, and a master in public health and DVM, in creating a simple infographic, you know, a one-page simple, what are the challenges? We don't know, there is extrapulmonary, TB is resistant to pyrazinamide, the treatment get complicated, we need to do something about it. Then we created the typical poster that we presented in a conference, you know, and then as a professors, we keep writing papers, you know, with Dr. Paula Fujiwara, a physician, and we just start saying in a human medical journals with clinical component to physicians treating patients, why it's important, and we need to think about extrapulmonary tuberculosis. We need to think about the innate natural resistance to pyrazinamide, which is the first drug you will give them to a human with TB. Therefore, if this human is misdiagnosed, you are giving them a drug for months that is going to do nothing to M. bovis. So we start really bring the conversation to the relevant sectors and stakeholders. We wrote a very influential paper on the Lancet infectious disease, the most prominent medical journal in the topic, you know. And as you can see here, it was a call for action, and it was collaboration between key stakeholders in different institutions, such as the World Health Organization, the OIE, the FAO, the Union, the CDC, the USDA. And we wrote this paper to say, we need to start acting about this disease. And this was in 2016. And then we wrote more papers. This is what professors do in science. We write these scientific papers in very good, prestigious journals. So we did our job. And even further, we wrote books. I was invited to participate with the colleagues in Ireland and the UK to write the newest book on bovine tuberculosis in 2018. And we have our chapters about zoonotic tuberculosis. And recently, this book was published now in the year 2021, a few months ago. We also were invited to write about zoonotic tuberculosis. So this is the book that veterinarians will read. This is the book that physicians will read. And in both books, we have been able to work across the dividing line between the human medicine and the veterinary sector. So has been great news. But really, a key moment in these last 10 years was when Dr. Paula Fujiwara at the Union, she said, Francisco, you need to meet journalists. If you really want to do something at the global scale, all these papers, all these books, all this work is great, but it's not enough. You need to get the message in a different way, not just in scientific journals or scientific books. So I started working with these 2 journalists, excellent, top class, serious journalists. And they say, all right, so 1.4%, they came with the same number, who cares? I say, all right, so they told me in 5 seconds, tell me, why should we help you? Why should we start a global campaign if it's only 1.4% and really we have more than 9 million people with human TB? So I have to think for 30 seconds on my response, because I knew that whatever I answered was going to be a yes or a no from them. And I told them, well, it's very simple. If the WHO is really serious about ending TB by 2030, you need to end every type of TB. And if you don't focus on M-bovis, you will never end TB. And then the two of them, they smile and say, let's start working. So the power of communication. And then when we start working with them, it was completely a new world for me. We were very rapidly, within a year, on the major global news. BBC in England, CNN in the United States, World Press Conference with the, at that time, director of the tuberculosis program at the WHO, Dr. Mario Rabliglioni, Dr. Paula Fujiwara, all physicians, Paul Van Helden here from Africa, Simeon Cadmore from Nigeria, giving all this, at that time, in-person press conference. And then the issue of zoonotic tuberculosis went to almost every major media outlet in the world, in South Africa, Le Monde, in France, in Spanish, in English, in French, and in different languages. You see YouTube channels, little cartoons, and more press conference, and at the BBC again. It really the work that these journalists did to do what they do, communicate, is something that as a veterinarian, as a scientist, of course, I don't have the skills to do. So that collaboration was key. All that work brought people to us, patients, people that suffer from this disease, zoonotic tuberculosis. So we have a veterinarian from England that suffered from the disease, that learned about, saw us on the news, contact us. So we start working with the community, with the affected patients, a person in Kenya. I will get back to Team Pijan very soon. And we start working with the community. As I say, in those times you can travel. So we traveled to Uganda, we start collaborations with Uganda, and we went to those areas in which this is indeed a serious problem. But we didn't stop just there. We contact politicians in England, London, England, and advocates and people that care about TB. So we mobilize the decision makers, the politicians, and start working with the major organizations such as the Stop TB Partnership, in which they created a new tuberculosis plan. And for the first time, after a global consultation online, for the first time ever in their plan to stop TB, they include people affected by zoonotic tuberculosis. That was a major win, to have zoonotic TB on a page in the global plan to end TB. And of course, we didn't stop there. We went to work with the WHO in the headquarters in Geneva, again with all the major key players from these organizations. Here you can see are our folks from the UK. And then we went and presented there the case of zoonotic tuberculosis at the Strategic Technical Advisory Group in June 2016. Here we are presenting with colleagues from WHO, colleagues from OIE, colleagues from the union, myself, and this ended up in us successfully published for the first time the official roadmap for the zoonotic tuberculosis, endorsed by the union, the World Health Organization, the World Organization for Animal Health, and the Food and Agriculture Organization of the United Nations. In this roadmap, it has been a very key document that highlight 10 priorities in 3 different pillars, and these include the development of science, the collection of data, the minimizing the transmission across the humans-animal interface, and also strengthening intersectoral and collaborative approaches across different disciplines and sectors. We went further, and in the year 2018, we reached out via Dr. Paula Fujiwara, the United Nations, the General Assembly that happened once a year, and for the first time, all the presidents signed and supported that tuberculosis need to include, the control of tuberculosis need to include zoonotic forms, and also people and communities at risk of exposure to bovine tuberculosis. So this is an official document of the United Nations, and the presidents of all the countries signed this one. This one, of course, led to the main organizations in the world to remove zoonotic tuberculosis, or actually give more priority to zoonotic tuberculosis. And actually, even when you click now some of these websites, you very rapidly will find their information on zoonotic tuberculosis and how these have become a priority for them right now. To the point that in the year 2000, I think 18 was the first time, but I'm showing here one more updated. Now in the official WHO report, you find, again, a page or a page and a half, depending how much they write, about zoonotic tuberculosis with some global estimates. And as you can see here, the global estimate was 1.47,000, almost 150,000 new cases a year, with a tremendous, very, very large uncertainty interval that could be anywhere from 70,000 to 250,000. But again, this is indeed, I will agree with Feliciano, a very big underestimation of what really is there. Why? Because as today, 2021, other than the United States and the United Kingdom, there are no other countries routinely typifying all their human TB cases to see if they were either MTB or MBOVIs. And especially in those areas of high risk, such as some areas in Mexico, Africa, Asia, there is not just the money to do it, all right? And also because the laboratory techniques used to grow or identify or diagnose a patient don't favor the growth of Mycobacterium bovis. So whatever estimate is out there is most likely just the tip of the iceberg. So with this, and to start concluding soon, I realized, I learned from communicators that we need to do something else. So last year I created actually the Zoonotic Tuberculosis Network. This is available online, anyone can join. And it's just, if you just Google the Zoonotic Tuberculosis Network, it will appear. And this is an online platform to connect stakeholders working from any angle, from any organization, from any views that want to do something about zoonotic TB. And we have different resources, videos, all the publications, well, not all, we update them every year, and books and web pages and news, etc. So it's a very, very interesting webpage. I can tell you now that in the last year, and actually this year, 2021, we have some very interesting developments. The OIE created a group for new strategies to control Mycobacterium complex infection in livestock, so in bovines. And I was invited to participate here with many of the colleagues that I already mentioned. But most importantly, the Global Fund this year in April 2021, and after some consultations in which Dr. Fujiwara, myself, and many others participated, approved officially and endorsed that for the year 2023, their budget will have a One Health approach for fighting AIDS, tuberculosis, and malaria. And that's a tremendous success that now the Global Fund officially recognized this and they're going to put some money. How much and for what, I don't know, but step by step. Some recent examples with colleagues in the United States, with economists, anthropologists, and myself, the veterinarian, and here with the leader of this project, Dr. Tad Miller from the University of Northern Texas Health Science Center. So again, a human institution, a human medicine institution. We submit this project to the CDC, and this was a $5 million project for 5 years. And very interestingly, we got it approved, but not funded. It was a very interesting letter that say, congratulations, you made it all the way. And we are really excited that you want to study, use the One Health approach to study tuberculosis in high burden settings. My work was in Uganda. We have another branch in the Caribbean. We like it, we approve it, but sorry, it's the year 2021. We will not be able to allocate the money. So that was a very big disappointment because we worked for many months on this project and unfortunately they were not able to give us the money. They liked the project, they approved it, but they didn't give us the money. But again, another example of collaboration between economists, anthropologists, and myself, a veterinarian. I mentioned already Kenya, Timpijan Leseni, she's a zoonotic tuberculosis survivor, and she is the founder of the Talaco community-based organization. So with Timpijan, we met in some of these conferences and work, and we are starting projects in Kenya that thankfully I'm being able to now obtain the money from my own university, Western University in Canada. And we have 2 projects. One is to address the social reality of tuberculosis volunteers, people that just volunteer to go and help with different aspects of tuberculosis, diagnosis, treatment, transporting samples to the lab in a very unique rural environment, focusing on the Maasai community in Kenya. And we are working, of course, with an anthropology anthropologist Dr. Elise Nové from Western University, the Faculty of Health Science, and an MPH, a Master in Public Health, Dr. Elena Andoniu, also from Western University from the One Health program. So again, a combination of community, the people suffering from the disease, all the organizations in Kenya, and myself, the veterinarian. And also I got another project, very minor, pilot project approved with my own master student, Joel Sang, Antin Pijan-Leseni, in which we will be looking at healthcare facilities in these rural areas and see what are their capacities, their logistics, and their knowledge regarding human TB and bovine TB and zoonotic TB. A minor pilot project, but still very interesting. So those are just some examples about how the One Health approach, a true One Health approach, certainly combining human and veterinary medicine, but beyond that, it have been used for trying to address some examples at the global level, but also in some very specific settings. So to conclude, I think, and this is completely personal, I think that to address the challenges posed by zoonotic TB today globally, and certainly in Mexico, and certainly in Michigan, and certainly in Africa, what really is needed is a mindset shift. We need to change how we do things, how we approach health. And as I like to say to my students, when you are trying to change something, there are three things that need to happen, and I call them the 3 A's. First, you need to be aware that there is an issue, then you need to accept it, and then you need to act. I think today with zoonotic tuberculosis, we have done a very good job in creating awareness, but more work is needed. In the part of acceptance, there are still people that we need to get the message in a different way for these key stakeholders to accept. And then there is a tremendous room for improvement and a need and major work to be done to start acting on addressing these challenges. And to address this challenge, I will just echo the work of some very famous doctors, one veterinarian and one physician. Dr. David Walter Tace from my alma mater in Canada, the university that I got my master and my PhD, the University of Guelph, the Ontario Veterinary College. He basically said many things about zoonosis, but one is that to really understand and therefore to be able to address zoonosis, you need contributions from many disciplines and sectors. He, of course, includes veterinarians and physicians, but also historians, anthropologists, and I really like how at the end he said, just plain folks. And in this case, it's the people that are affected by the disease. And echoing Dr. Jane Carter, a current professor at Brown University in Rhode Island in the United States, and the former president of the union, she once mentioned to me, Francisco, what's knowledge if you don't use it? And I think those two things are extremely important because indeed to address the challenges posed by zoonotic tuberculosis, science, knowledge, what people like me and many others do in academia, in research is absolutely necessary, 100% necessary, but not sufficient. Therefore, collaboration across different sectors and disciplines is critically needed to actually act and create the message for people to accept and act. And I think that One Health presents an extremely robust and comprehensive approach to start addressing these challenges. And with that, I would really like to again thank you for your attention. Thank you again to the organizers and the audience, the attendance to this presentation. And again, thank you. I mean, of course, thank you to all the people that have collaborated in this tremendous effort over the last 11 years to bring zoonotic tuberculosis to a more, to be a priority and for all the work being done. Here is my contact information. And if you have any questions, I look forward to answer them. Thank you very much.
Agradecemos al doctor Francisco Olea por una excelente presentación.
We thank Dr. Francisco Olea. It's incredible the amount of information that we were probably not aware about the One Health strategy and all of the issues that zoonotic TB presents. We have many questions and I'm going to start. the first question, how to measure the impact on the TB, on the zoonotic TB cases when we don't even know the real prevalence of this disease in population?
Excellent question. So if I understood the question is how to measure the impact of zoonotic TB, correct? If we don't really know the real numbers, right?
We don't even know the prevalence in the population.
Excellent. So that's an excellent question. And the first thing to do is you need to start counting. If you don't know, you will never be able to get the message across to those people that actually can start measuring the impact. What we have done so far is having this initial estimate of 147,000, I think now went to 151, is to have it there in an official document so people can start grasping this. For example, if you ask me that, I will say, well, 150,000 cases, new cases a year is significantly higher, tremendously higher when you compare to all the zoonotic flu bird or avian influenza cases that occur in the last 18 years, maybe globally. So you see, communication is very important. And the people that make the decisions, the people that contribute with the money need to be told these things in simple terms. Another way that you can start addressing this is by working with the people that have suffered from this, such as Tim Milián, such as the veterinarian in London, England in 2016, in a developed country in which he almost died. He almost died because the physicians there were not able to diagnose this disease, and he, with his veterinary training, became an advocate of himself, sorted out what happened, when he got exposed, how he got exposed with his work with animals. And although that is an N equal one person here, one person here, and then now we have the cases emerging and being published in Michigan, now in 2021, in a developed country. Plus the work that people like professors and academicians doing selective studies that are, again, with 20 people or 100 people, certainly no nationwide representative. That's the beginning. That's the beginning, how you can start addressing the impact. But also what you can do is, with the available knowledge, the knowledge that we have today, and the fact that nobody is looking for MBOVs, and when they look, they are not even the right tools, the numbers we have today are certainly, I can comfortably say certainly, a big underestimation. And if you understand, with the knowledge we have today, that many children suffer from this disease, and children die from this 100% preventable, treatable, and curable disease, I don't know what else is needed to start acting. When you can prevent, treat, and cure a disease, but we are not doing it. That's what I like to tell the people that have power to make decisions. People are dying, and this should not be happening.
Muchas gracias. La siguiente pregunta dice, desde la
Thank you so much. The next question is, from the perspective of One Health, what strategy could be implemented in order for professionals who study tuberculosis in humans and those who study tuberculosis in animals could work together? Because at least in Latin America, that's almost impossible.
That's an excellent question, and Feliciano already mentioned this. The dividing line between the veterinary and the human medical sector, for me, is something that is hard to comprehend. And the activities, what specific actions could be put in place, are going to be 100% dependent of the specific country or a scenario that we are trying to work with. I can give you some examples, some concrete examples. A physician in Michigan, Dr. James Armstrong, he's a Canadian physician working in the United States in Michigan. He is being a champion because he has seen these human patients. He has treated these human patients with bovine tuberculosis. He knows the story of these people. We were talking last week, and he was telling me, I went, and for the first time, I went to an entire weekend to test cows, hundreds of cows. I have no idea how veterinarians work, the amount of work you guys do to test hundreds of cattle, inject tuberculin, wait 3 days, come back, it's raining, it's cold, it's muddy. So I think, and he's putting together human doctors and veterinary doctors. He has developed a couple of real-time in-person workshops. Now he does it over Zoom. He's publishing papers. And as I say, it really depends of the country, of the region, and it really depends of finding the champions. And they are there. Unfortunately, the silo approach and the division between sectors, and actually the competition between sectors and the egos between sectors and professions is a barrier. It's a barrier, the professional culture that we have. I work for this agency and we do this one, and like a racehorse, we move forward here and we don't see to the side who could we complement our efforts. And trust me, there are plenty of people out there that would like to work this way, but you need to find them. And it's not easy, but they are there. And when you find the Paula Fujiwaras, when you find the Tim Pijans, when you connect people like me with people like Alejandro Pereira in Mexico, you know, we're across countries and still we can work together. Things actually do happen, but it requires an extra personal effort because the current channels, the current structure of institutions, and even the competition sometimes between universities and the competition for very small research money create these frictions. And you just need the mindset to start acting different.
Muchas gracias. Otra pregunta. Si cada vez son más frecuentes los casos de tuberculosis en humanos,
the human tuberculosis are more frequently, which are provoked by M. bovis, why don't you typify these cases, considering that M. bovis is resistant to ferripemicin? I hope that why isn't it typified? I hope the question was clear enough.
Yes, the question is very clear enough, and why you don't typify all the cases. Many reasons. The first one, cost. It costs money. It's not cheap. Second one, logistics. The United States today typify them all. The numbers that I show from 2010 were 1.4%. I think the last paper in 2017 or 18 that I read by the colleagues at the CDC was 1.5%. A slight increase, but still an increase. And but when you go to countries like mine, like Chile, or most of the countries in Africa, the resources are not there to sample everyone and do the duplicate type of work to culture this in a culture media with a pyruvate, you know, which is different than the one that is used for normal human tuberculosis. But that's the key, because you see, the veterinary sector have all these techniques. The veterinary laboratories, they know how to grow Mycobacterium bovis, and they do have all the reagents and media and knowledge to do it. So there are two things: collaboration between the human and veterinary, or the laboratory works, or a national health veterinary agencies is essential for this to start working a little bit better. There could be collaboration, and that collaboration could be more cost effective. And secondly, I don't think it's a good idea, for obvious reasons, to start trying to typify every single human TB patient in the world, just simply because the epidemiology of the disease, the vast majority of patients are still going to be human TB. But in those areas in which there are clear epidemiological or socio-cultural, economic, religious factors, and also in areas in which we already have some data that say, yes, M. bovis is circulating in humans, M. bovis is transmitting to humans. And then if you have a patient that come to your clinic that say, yes, I'm a farmer, or I drink unpasteurized milk, and we know we have milk M. bovis in cows, and you start doing all that clinical history, use the knowledge epidemiology, as already Feliciano mentioned, you can start typifying those high-risk patients, such as the ones that, for example, don't respond properly to the initial TB treatment, right? So you don't need to try to typify 10 million people, but you need to be practical, realistic, use the available resources and logistics, and try to target those most at risk under the current economic and financial constraints for this particular disease. I think that's the approach. That it can be done, medically speaking, yes, it can be done, but there are other factors, and that's the reason why One Health is so important, because you need to understand these factors and you need to work a way around.
Bien, muchas gracias. Más preguntas, doctor. Dice la siguiente. En el último
Next questions. In the last report from the World Health Organization, it was reported Mycobacterium bovis in humans. But which countries are the ones that have a systematic report of these M. bovis in humans?
Excellent question, and an excellent question. And to be perfectly clear, in the very last, in the 2021 report, the one that was just published, I think was October 14, so a month and a half ago, actually M. bovis was not there after 3 years that they put it there. And that is, again, another casualty of COVID. And we are inquiring now via the union why M. bovis was not put there. And the response we have get so far, we will have an official response, and we are working. They also, as we know, the WHO has been under tremendous constraints and challenges. And the entire report in the last year, it was different than the previous one. So that was another casualty. But anyways, the estimates that are there, that have been there for the last 3 years since they put them in for the first time, and the one that now they will put on their webpage most likely, is an estimate based on epidemiological mathematical modeling from the available data. And specifically from one scientific paper that was published in 2000, I think it was 16, I forgot the year, by colleagues in Europe, in which they did a meta-analysis, a systematic review and a meta-analysis, and they came out with this estimate for regions, Africa, South America, Asia. So it's really an estimate, because the only countries today that are doing it are the United States via the CDC, and you need to understand in the United States there are roughly only 9 or 10,000 human cases a year, 10,000 for a country of 350 million people, and with all the resources they have, so they can do it. The United Kingdom a few years ago published for their 4 countries, England, Wales, Scotland, and Northern Ireland. They are also doing it in a routine basis, but also there are very few cases of tuberculosis in those countries. The problem is that we really need it in the countries such as in the high burden TB countries, in the 30 high burden TB countries, African countries, India, and other countries in which human TB is high, bovine TB is high, and the sociocultural factors are there for transmission. And that's a money thing. So the estimates available there is a combination of the available data from some countries plus all these other studies that are mentioned to you that actually are not representative from countries. So that's the reason they presented by regions, continents. I hope that answered the question.
Bien, tenemos tiempo para una pregunta más.
We have time for one more question. I'm going to formulate it. What are the main issues that exist globally so that a systematic report is not done on zoonotic tuberculosis?
Actually, thank you for that question. And that was the question that a student asked me 2 weeks ago in a lecture that I gave in the Master of Public Health in my university. The question actually they asked me, well, what's the main priority, right? Or what's the main issue? What's the main priority that needs to be addressed? And my answer will be the same right now. The main priority or the main issue is that the priorities need to change, period. The priorities need to change. We can talk all the day about culture media or reagents or Petri dishes or PCR or whatever from the medical point of view. The knowledge is there. We know how to find these people. We know how to test. We know how to diagnose this disease, zoonotic tuberculosis in humans. We know how to treat it. We know how not to treat it. And we know how to cure people. We know all that, but it's not being done. And this is not happening just to 10 people here and there. It's by the hundreds of thousands every year, and this includes children that have an entire future. So if you ask me this question a year ago, 10 years ago, or right now, I will have the same answer. The priorities need to change. The funding mechanisms need to change. And the willingness to do what is needed to better prevent, better diagnose, and better cure this treatable disease is what's needed. That's the main challenge. It's a psychological challenge, economical challenge. It's a challenge of priorities for those making the decisions to understand, and I mean all of them, from national leaders to global leaders, to the physician, to the people buying the food or the milk in the market, education. You know, it's the entire One Health umbrella that needs to start working here to change this for zoonotic tuberculosis and for other similar diseases, such as rabies, another classical zoonosis that we learn in the veterinary school and college, a 100 preventable disease, and still we have thousands of people with a great number of children dying from a disease that we, the people that have the knowledge, we know how to prevent and even to treat if you get bitten by a dog with rabies before the symptoms develop. So it's a mindset. It's a real mindset. And I think if anything we can say has been good about this COVID-19 crisis is that finally the global leaders have understand the connection between human, animal, and environmental health. And hopefully we are starting the era in which all these challenges that are between professions, between countries, between institutions, between sectors, hopefully humanity will understand that we can do much better if we work together rather than against each other and competing and putting our egos first. If you really care about human health and animal health and environmental health, there is certainly a way to do things and a way not to do things. So changing the priorities, that's the main challenge.
Muchas gracias, doctor Francisco Olea, por tanta información increíble.
Thank you so much for all the information. Unfortunately, we're running out of time. The questions that we were not able to address are going to be sent to our different presenters today so that they can answer them on their time. With this, we conclude today's session. We would like to thank the doctors, our speakers, for the excellent topics that were presented today. We would also like to thank again the study centers and audiovisual production of the University of Baja California for the transmitting of this session, as well as to our sign language interpreters and our language interpreters. And we would like to remind everyone to register your assistance to this session through the QR code so that you can get this, the corresponding certificate. The QR code is only valid until the end of today's session. We also thank all of you for being present in this 7th session, and we invite you to the next one next week, the number 8th and last one under this tuberculosis forum, on which we're going to have 2 excellent speakers, Professor Pierre Balding, California University, Irvine, California University, who's also a part of the biological imaging. We're also going to have someone from the United Nations Office for Progress Services in Geneva. She's part of the X-ray Innovation Department, as well as in artificial intelligence for the response to the tuberculosis program. Thank you so much to everyone. And with this, we conclude today's session. Have a good day.
¿Estamos fuera del aire?
No, a ver.